Now, let's go to the confidence level for the mean when the standard deviation of the population is unknown. In that case, the confidence interval for mu when sigma is unknown is x bar plus or minus. Instead of using the standard normal distribution, we are going to use another distribution called t distribution of alpha divided by 2 with n minus 1 degrees of freedom times what? Instead of using sigma, because we don't know what is sigma, we are going to use the standard deviation of the sample divided by the square root of the sample size. Now, what is this t distribution? Okay, let's say that this is a normal distribution, that the mean is equal to 0. The t distribution is very, very, very similar to the normal distribution. Is also a bell-shaped distribution. Is also the mean equal to 0. However, if I draw the t distribution in this case, what I'm going to get is something like this. Okay. Okay, this would be the t distribution with whatever degrees of freedom it is. As the degrees of freedom is increasing, this t distribution goes more similar to the normal distribution. So this is the standard normal distribution, and this is a t distribution. As you realize here, the t distribution is a more conservative distribution. Okay, it is shorter and fatter, because what at the end is going to give us is a wider confidence interval. So we are going to use the t distribution. And fortunately, the t distribution, we have table for the t distribution, and the t distribution is on page 981. And as you can see over here, this table gives us that part of the graph, the right tail of the graph. But again, this is a symmetrical distribution, so everything that is in the right side is exactly the same as the left side. The first column is the degrees of freedom. Okay? The degrees of freedom, and we are going to use the degrees of freedom n minus 1, where n is the sample size. So it's pretty easy. And we are going to use alpha divided by 2. Okay, let's go back to where we to make a problem. Let's do problem number 16. The mean number of hours of flying time for pilots at Continental Airlines is 49 hours per month. So I'm going to raise this. So it's saying that the mean number of hours is 49. This mean was based on actual flying time for a sample of 100. So we have a sample size of 100, and the sample size, and the sample mean was 49 hours. And the sample standard deviation, they don't give us the population standard deviation, they give us the standard deviation for the sample, that is S is equal to 8.5. Now, what is the margin of error at 95? And B, what is the confidence interval? So since we do not have the standard deviation of the population, then we are going to use the formula x bar plus or minus t of alpha divided by 2 and minus 1 s over the square root of n. We have s, we have n, we have x bar, but we don't have the t. What is this t? Okay, go to the table. Go to the t table. That again is on page 981. And we are going to use, for the degrees of freedom, n minus 1. N is 100, so the n minus 1 has to be 99. So it's on page 982. And look for 99 over here. We have 99, 100, and then infinite. Okay, let's do 99. Okay, what is the alpha divided by 2? Guys, alpha is the significant level, the confidence interval, the alpha, and alpha divided by 2. Remember this. We are dealing with 95 confidence interval, so alpha is 0.05. Alpha divided by 2 is 0.025. Okay? Because this is alpha divided by 2, 0.025, since we are dealing with 95% confidence interval. So what I'm going to do is to read under 0.025, because we are dealing with alpha divided by 2. It's not alpha, it's alpha divided by 2. So it's 0.025 and 99. My t is equal to 984. Okay, that's it. We have everything else. So this is the margin of error. S is 8.5 divided by the square root of 100, and that is equal to 984. 1.669. So my margin of error in this case is 1.69, such that my confidence interval, that is the B part, is confidence interval is going to be 49 plus or minus 1.69, and that is 47.3 until 50.69. Okay? What I'm saying here is that I am 95% sure that the real population parameter mu, the mean of the population, is between 47.31 and 50.69 based on the sample that I have here. That's what I'm saying. Okay? The C part says the mean number of hours for flying time for pilots at United Airlines is 36 hours. For Continental is 49. So what implication does it have? Well, the United Airlines pilot fly less hours, so it means that they have to have more pilots, so they have to have more costs or whatever. Okay, that's it.